Welcome to this Java socket programming tutorial. In this video, we will embark on a journey to understand the foundational concept of a socket programming in Java. Whether you are a beginner taking your first steps into the world of networking or someone with prior experience looking to refresh their knowledge, you are in the right place. This tutorial is designed to cater to all experience levels, providing a solid foundation and preparing you for more advanced topics in the future. So let's dive in. What are sockets? In the world of network programming, sockets are the backbone of communication. Think of them as communication endpoints. Just like you plug your phone into a socket to make calls, devices use network sockets to talk to each other. They are the bridges over which data flows between devices. Alright, let's delve into our first code example to get hands-on understanding of sockets. In this snippet, we are creating a basic socket in Java using the socket class. Now, let's break down what's happening here. We start by importing the socket class from the java.net package. This class represents a socket, which is essentially an endpoint for sending and receiving data. In the main method, we try to establish a connection to a remote server located at example.com on port 80. The socket object named socket becomes our communication link to that server. Here is where the magic happens. Between the creation of the socket and its closure, we would typically perform operations like sending or receiving data. Think of it like picking up the phone and having a conversation. The socket is used as a channel for communication. Finally, it's crucial to close the socket when you are done. It's a good practice and helps free up resources. This code snippet is a fundamental building block for understanding how sockets work in Java. It forms the basis for more complex interactions we will explore in the following sections. So, let's move forward and dive even deeper into the world of socket programming. Types of sockets. Now, let's explore the two main types of sockets in Java, TCP and UDP. TCP or Transmission Control Protocol provides reliable and ordered communication. It's like sending a certified letter where you want to make sure it arrives and in the right order. UDP or User Datagram Protocol is fast but not as reliable. It's like sending postcards. They may arrive quickly, but you can't be sure if all of them will make it. Consider a web browser like the one you are using right now, which uses TCP sockets to establish a reliable connection to web servers. On the other hand, online gaming often uses UDP sockets to ensure low latency communication, even if a few packets are lost. This choice of socket types depends on the specific requirements of the application. So, how do you use sockets in Java? Let's discuss the typical steps involved in socket programming. The process starts with creating a socket. This initializes your communication endpoint, allowing you to send and receiving data. Next is binding of server side. If you are building a server, you need to bind your socket to a specific local address and port. This means specifying where the server will listen for incoming client connections, then connecting client side. On the client side, you will connect your socket to the server. This is done using the connect method. It's like picking up the phone to call someone. You establish a connection to the other end, and then once the connection is established, you can send and receive data. This is where the real communication takes place and information flows between the client and the server. So actually, this code snippet illustrates the first step in basic socket programming, creating a server socket to listen on a specific port. In our case, port 12345. It sets up the server to accept incoming client connections. Before we jump into writing code, it's essential to ensure you have right development environment in place. If you haven't already set up Java 17 and IntelliJ IDEA, don't worry, I have got you covered. I have created dedicated video that guides you through the installation process step by step. You will find the video link in the description box below. Take a moment to watch it and ensure you have the Java Development Kit JDK and installation IDEA installed. Once you are all set, return to this tutorial and we will dive into the fascinating world of socket programming. Let's move on to the exciting part, writing creating your first Java socket program, we will start with a simple client-server application. I will walk you through the code step by step, explaining each part along the way. The client and server will exchange message to give you a hands-on experience. This code represents a simple server application that listens on a specified port for incoming client connections. When a client connects, the server creates a client handler thread to handle that particular client. In the server class, main method initializes the server socket and listens for incoming client connections on a specified port, in our case 12345. Upon accepting a client connection, it creates a client handler object for each client and starts a new thread to handle communication with that client. Client handlers list maintains references to all connected clients. Client handler class handles communication with the individual clients. The constructor initializes input and output streams for communication through sockets. Run method reads messages sent by the client and broadcasts them to all connected clients using the broadcast method. A key point is the server accepts multiple clients by creating a client handler thread for each client. Each client handler handles incoming and outgoing messages for its specific client. The broadcast method sends a received message from one client to all connected clients. Now let's create the client class. Now let's establish the connection. The client program defines the server address as localhost and the server port is 12345. It creates a new socket and attempts to connect to the server using the specified address and port. Now then it sets up the output stream print writer out to send data to the server via the socket's output stream socket.getOutputStream. It establishes the input stream buffer reader in to receive the data from the server through the socket's input stream socket.getInputStream. Another buffer reader console input is created to read user input from the console standard input. For sending and receiving messages, it enters an infinite loop to continuously send and receive messages. Asks the user to input a message through the console, sends the user's input message to the server by writing it to the print writer out.println message, receives the server's in response message through the buffer reader in.readLine method, prints the received messages from the server along with the server to the console. Finally, we are handling the exception. Catches IO exception if any input or output operation encounters an error and prints the stack trace. The summary is this client program establishes a connection to the server, allows the user to input messages from the console, send them to the receiver and displays the server's response on the console. It operates in a loop, facilitating ongoing communication until manually terminated or an error occurs. With the code written, let's run and test our application. Here are the steps. Run the server program. Run the client program. For successful connection, you should see client connected on the server and server says on the client confirming a successful connection. Let's enter welcome to our Java socket program. Now you can see the message displayed in both the client and server places. The successful exchange of message between the client and server validates our test of communication. Socket programming can be an exciting journey, but it's not without its challenges. Here are some common issues you might encounter when working with sockets. First one is network issues. Challenges: ensuring that the client and server can communicate over the network can sometimes be a hurdle. Firewalls, network configuration, and routing issues may restrict or block connections. Tips and strategies: check network connectivity and ensure both client and server are on the same network. Verify firewall settings to allow traffic on the specified port. Use tools like ping or telnet to test network reachability. Example, if your server is behind a firewall, make sure to open the specific port you are using for socket communication. Example, port 12345. Next one is port conflicts. Challenges: port conflicts occur when the port you intend to use for socket communication is already in use by another application. Tips and strategies: choose ports that are less likely to be occupied by other applications. Use tools like Netstat to check for port availability. Consider dynamic port allocations if available. Example, instead of using well-known ports, example 80 for HTTP, choose a less common port like 56789. Next one is exception handling. Challenge is socket programs can throw exceptions such as IO exception due to network errors, disconnections or other issues. Handling this exception is crucial. Tips and strategies: implement proper exception handling in your code using try-catch blocks, log error details to aid in troubleshooting. Gracefully close sockets in case of exception. Example, in your code, use try-catch to handle exception and log error messages for debugging. And then security. Challenges: security is a paramount concern in socket programming, especially for sensitive data. Encrypted communication can lead to data breaches. Tips and strategies: implement secure socket protocols like SSL/TLS for encryption. Consider using authentication mechanisms to ensure data integrity and confidentiality. Regularly update your applications and libraries to patch security vulnerabilities. Example, you can secure your socket communications using the javax.net.ssl package in Java and configure SSL certificates. By addressing these common challenges and applying these tips and strategies, you can navigate the complexities of socket programming with confidence. This will help you create reliable and secure networked applications. Congratulations, you have now learned the basic of Java socket programming. You can use this knowledge as a foundation to build more complex networked applications. In the real world, socket programming is used in various applications, including chat applications. Many chat applications use sockets for real-time communications, and then multiplayer games. Online multiplayer games rely on sockets for player interactions. Then remote control systems for remote control, monitoring and management often employ sockets. Data streaming: sockets are used to stream data between devices and servers. The possibilities are vast and you can apply socket programming in different domains. If you have any questions or need assistance with your socket programming projects, feel free to leave a comment. Your next steps can include exploring more advanced topics like concurrent server handling, secure socket communication, or building real-world projects using sockets. The world of network programming is vast and exciting, and you have taken the first step. If you found this tutorial helpful, please like and subscribe for more content. Thank you for watching this tutorial.